Good afternoon. It's my pleasure to introduce to you Mr. Marvin Odum, President of Shell Oil Company. He's also a director of Upstream Americas, which is the Royal Dutch Shell subsidiary of in the Americas. Mr. Odum holds positions of board leadership and participation in the Business Roundtable and the American Petroleum Institute. In addition, he's also a member of the Dean's Council of the John F. Kennedy School of Government at Harvard, and he's on the advisory board of the Cockrell School of Engineering at University of Texas at Austin. He serves on the University Cancer Foundation Board of Visitors for the University of Texas MD Anderson Cancer Center and is involved with several other Houston area charities. Mr. Odum earned a bachelor's degree in mechanical engineering from UT Austin and a master's degree in business administration from the University of Houston. He began his Shell career as an engineer in 1982 and has served in a number of management positions of increasing responsibility in both technical and commercial aspects of energy. At this time, please welcome Mr. Marvin Odum.
Thank you, Steve, and good afternoon, everyone. Really a privilege, of course, to have the chance to come and share some thoughts with you. And easy to sit here and say that it's pretty humbling as well, because as I look around the room, it's pretty obvious to me that I'd probably be much better suited to sit there and listen to what you have to say rather than presume that you want to hear my insights into to this topic. But nevertheless, I'm going to take a few minutes to suggest a way of thinking about my business, which is the business of energy. And it may be in a way that might surprise you, in a way that I hope connects to the vital work that you're doing in your respective disciplines. And as I try to do that, I'll offer some perspectives on why the enormous human and environmental and economic challenges of the 21st century cry out for leadership from individuals who are at the top of their game in the fields that you represent. And I'll give you fair warning that I'm going to close with a relatively heavy proposition, namely that the health, security, and sustainability of the world that our kids will be sharing with 9 billion neighbors by 2050 depends on people like us working together now on smart answers to some really tough questions. But I'll start with a little bit of a commercial message, and you knew this was going to happen, didn't you? If you look at our company, Royal Dutch Shell, through a conventional lens, you'll see the second largest oil and gas business in the world. Now, most people know us best through the products that we sell to consumers: gasoline, diesel, and engine oils. Now, that's not surprising once you realize that Shell has more branded retail sites than McDonald's has restaurants. But that's just the very tip of what we do. And if you look out your window before the next airline flight takes off, you'll probably see a Shell truck pumping jet fuel into your airplane. Just one out of 7,000 aircraft that we refuel at over 800 airports in 40 countries every day, about one every 12 seconds. Now, admittedly, you'll be less likely to see Shell fuel and lubricant flowing into one of the ships that we service in over 600 ports worldwide. And you can't see the 22 million tons of Shell chemicals that go into products that you use every day, from detergents to packaging, from carpets to computers. But even all these things represent only one end of the value chain that we manage. In the U.S. alone, we move more than 2 billion barrels, or 80 billion gallons of oil and refined products annually, by way of many thousands of miles of pipeline. Now, worldwide, we use many thousands of tanker trucks and over 60 world-class ships to get product where people need it, to power plants, airports, harbors, Walmarts, Jiffy Lubes, gas stations, and a lot of others. And before we move it, we refine it, turning natural gas and crude oil into materials that people can actually use to move things, to make things like paint, shampoo, and plastic components for medical equipment, and to power things like computers, washing machines, and Xboxes. Now, in the U.S., Shell has the capacity to refine more than 1.3 million barrels, or over 54 million gallons, of product every day, using cutting-edge chemical, thermal, and physical reactions, running at temperatures and pressures that rival any other man-made process on Earth. But refining still only represents the halfway step in the journey that links the sources of energy to its use. That journey starts even further upstream, in reservoirs of oil and gas, under the ground, underwater, under ice, in sand, and thanks to the vision and perseverance of George Mitchell, and I know you all had a chance to talk about this today, in layers of shale. Now, the upstream infrastructure of our business is the biggest, least visible, and probably the most misunderstood part of what we do. For example, one of our newest upstream production platforms in the Gulf of Mexico is called Perdido. Now, Perdido is roughly 200 miles into the Gulf from where we sit today. And when you think of Perdido, think of a huge cork. Now, it is a multi-billion-dollar cork. It sits as nearly as tall as the Eiffel Tower. It weighs as much as 10,000 large family cars, and it's floating on the surface in 8,000 feet of water. Now think of that cork holding a crew of professionals operating miles of piping, thousands of valves, and hundreds of electronic safety sensors. And think of that cork tethered to the seafloor and a network of wellheads and equipment linked to over 100 miles of oil and gas pipelines. And alongside all of that are species of marine life that no human had ever seen before our remotely operated underwater vehicles snapped their pictures. Now, Perdido has the capacity to pump about 100,000 barrels a day. Now, to put that in perspective, it's enough energy to meet the needs of about 2.2 million American households every day. But there's 130 million houses in America, and 250 million cars on our roads, and more than 6 million businesses, both large and small. So imagine the number of Perdidos required to keep our economy running and to maintain our lifestyles and secure our future and to create jobs. And just in case you thought that was finally the end of the story, it's not. Because to keep all of that energy flowing, to meet a demand for energy by 2050, let's say, that will double what's needed today, we need to keep finding it and finding more of it, exploring in more and more difficult places, and using seismic technologies that require the world's largest and most sophisticated supercomputers to process the data. Now, the picture that I hope is forming is one of a massive, complicated, expensive global energy system that stretches from the most remote corners of the planet to the humblest of kitchens and classrooms and shops around the world. One in which Shell alone invests close to $30 billion a year of capital every year to grow and maintain the business. So by the way, all those boastful comments I made about Shell and what we do and the scale of investment, I want to give you a sense of the actual fraction of the world's energy that our company produces. And that's a grand total of less than 3% of the world's needs. So to keep this massive system running safely, responsibly, and reliably is a technical challenge that rivals space travel, or I would say any other human endeavor, for its sheer breathtaking scale. You as an audience are much better equipped than most to imagine just how technically demanding it is to find, produce, make, and move and sell hydrocarbons, working at temperatures that range from 160 degrees below 0 Celsius to liquefy natural gas, to more than 800 degrees above 0 Celsius to transform crude oil into useful products. But even at that, the theme of this year's conference, Energy for Life, from human metabolism to powering the planet, and I'm glad you didn't go too small on the theme, but it did get me thinking. Now, this enormously complicated system that we've built over the last 100 years or so, that we use to run our cities and factories and economies, is not even as sophisticated as the energy system of a simple, single human cell. Now, nature has designed an energy plant 1/10 the diameter of a strand of hair that takes proteins, amino acids, and oxygen and converts it through the Krebs cycle with amazing efficiency into energy that we use to work, play, and stand up in front of an audience and speak. And nature has managed to produce and reproduce a nearly infinite number of these microscopic energy plants to fuel life of any sort, from exotic lichens in Antarctica to beef cattle in South Texas to the 500-year-old sequoias in California. And it occurred to me that if we are going to stand any chance of meeting the energy needs that we're creating for human societies, a need that will only increase for future generations, we'll need to find ways of creating energy that take at least a few crude, man-made steps closer to the self-sustaining, super-efficient, minimal waste ideal that nature has managed to produce. So how do we do that? Well, it starts with reducing the amount of energy that we throw away every day. And that means more efficient cars, aircraft, and computers. Everything from kitchen toasters to super tankers will need to consume less energy per unit of work than they do today. It also means designing better ways of organizing our lives. I found this fascinating. By 2050, 3 out of every 4, or 75% of the people on the earth, will live in cities. And that's up from 50% today. So now let's think about what that means. That's the equivalent of adding a new city of 1 million people every week for the next 30 years. So we have people at Shell working with the planners of some of the biggest and densest urban areas around the world to understand how to design cities to more efficiently and productively provide for human work, mobility, education, and culture. Now, with that as a backdrop, we take our responsibility to help address the energy challenge seriously, from developing breakthrough fuels and lubricants to increasing the efficiency of our own manufacturing and transportation. And importantly, by working to set the standard on the best way to recover resources. Now, given the natural gas theme that you've had this morning, I'll mention that we've developed operating principles for how we produce natural gas from tight sands and shale formations. And I've heard about some of the discussions that you've had earlier today with Mark and others in the room, and it sounds like it's very aligned with what I'm getting ready to say. These principles that we've put together cover the design, construction, and operations of our wells to ensure reliability and safety. They cover protecting groundwater and reducing our own water usage in the process. They cover protecting air quality and controlling emissions, reducing the physical footprint of our operations, and very importantly, engaging with communities on the social impacts of these developments, but also helping them take advantage of the huge economic benefits that these developments can deliver. Although we've designed these particular principles for our onshore gas business, I will tell you that it's similar to the way we operate everywhere, from the Gulf of Mexico to the oil sands in Canada to Arctic exploration in Alaska. We're also finding ways to be more efficient in finding and producing oil and gas, using techniques that can only be described in really highly technical terms like really cool. Now, I'll give you an example. And I'm sure the people in the room actually have much better examples than I do. But one is that researchers from Shell and Hewlett-Packard are working together on nano motion sensors, 1,000 times more sensitive than those in the Wii electronic game, to help us create sharper pictures of underground rock formations. At the other end of the scale is new floating liquefied natural gas technology. So imagine a vessel that's 6 times the size of the biggest aircraft carrier in the world. And we're building that today. Now, this vessel will have the ability to produce natural gas offshore, to liquefy it offshore, and to put it on tankers offshore and transport it to anywhere in the world. Now, I can imagine that some of you might be thinking, why only fossil fuels? It's great that you're working to minimize the impact of fracking and oil sands and offshore drilling, but what about alternatives? Hydrogen, biofuel, wind, and solar. Well, the answer to that is that all of these alternatives have their place, and they will be a significant part of a future energy system, as will others. And the answer is, we're working on them. For example, last year we formed a $12 billion joint venture in Brazil that is now producing over 2 billion liters a year of biofuels. Now, the sugarcane-based ethanol that we're producing there is the most sustainable, least carbon-intensive biofuel available anywhere at that scale. And this joint venture will be a platform for commercializing far more technically advanced, so-called second-generation biofuels that we're working on with partners in the US and Canada. And you've already heard from Dick Williams today, of course, about the potential that we see in wind. And we're exploring how we might best someday bring hydrogen fuel to our retail stations when we see that the automobile industry is ready for it. And I could go on, but, and you knew there would be a but, replacing any meaningful fraction of today's fossil fuel system with alternatives will require major technological breakthroughs, investments, infrastructure changes, public education, and highly intelligent policy frameworks. Current projections, and I know there are many, and maybe some in this room that think these are optimistic, are that roughly 30% of our global energy could come from alternatives to oil and gas by the middle of this century. But you have to remember, in that same time frame, the world is going to be needing twice the amount of energy that it needs today. So we continue to work on all fronts, making sure that we don't sacrifice the best solutions available today to the ideal solutions that we imagine for tomorrow. We continue to work on getting a few steps closer to that ideal energy system nature designed into the human cell. And we continue to expand our thinking about the role that energy and energy companies play in the bigger scheme of things. Because just as that human cell is a system within much larger systems that add up to our ability to think and feel and work and metabolize, so is our industry a system within a much larger integrated system that adds up to the ability of the planet and its resources to support our communities and economies. Now, let me give you an example. We need to take an especially close look at the nexus between water, food, and energy. And there's a powerful interplay between those three. Increasingly, it takes energy to produce dwindling supplies of fresh water in many parts of the world. It takes water, and lots of it, to produce certain kinds of energy. And it takes both water and energy to produce food in increasing quantities needed to support a dramatically growing population. Now, we could just let the need for those three resources compete with each other. Or we could work with governments and partners in other industry sectors and customers to innovate smarter ways to optimize the supply and use of water, food, and energy. That's why at Shell we're actively developing innovative technologies for reducing water that we use in our drilling and producing operations. It's why we're developing the biofuels I talked about only in places where they don't compete with food and water supplies, and learning ways to produce tomorrow's biofuels from agricultural waste. And it's why we're so focused on reducing emissions. Which finally brings me back to the proposition that I threatened you with at the beginning of the talk, and that is that it will take the integrated leadership of people like you and me in professions as diverse as medicine, engineering, science, and business, working together across sectors and disciplines to tackle the enormous challenges and opportunities confronting us in this still new century. Now, this is easy to say to this group. There's enough Texas in my DNA to further suggest that there are few more logical homes for that kind of work and thinking than right here, supported by organizations like this academy. And that's not just Texas pride talking. It's more a recognition of this state's responsibility in the world as a big place with big ideas, big resources, a big appetite, and a big heart. We are, in my view, the energy capital of the world, and when the world looks for ways to tackle the challenges of energy, from human metabolism to powering the planet, they ought to find some of the best answers right here. So thank you all very much for putting up with my comments, and I look forward to your questions.
Good. Appreciate you doing it.
Sure.
Do we have questions? have one for you.
Okay.
While they're thinking.
Yep.
It won't take them long, you know this group.
I know this group.
What about other disruptive technologies? Do you see some on the horizon that within the next decade or so could make a big difference, either on the supply or demand side?
You know, you'll find me as pretty serious about what's starting to sound like a cliche of not picking the technology. Yeah? So I'll just tell you how we think about it and how we run as a business, is we always hold out the possibility that those breakthrough, game-changing technologies are out there. I don't think we know exactly what they were. If we knew what they were, or if we thought we had a really good idea of what they were going to be, that's where you'd see us, of course, chasing with our investments and otherwise. So our investments do reveal what we know about the world today. But I think it does speak to how we view research and R&D, technology, and so forth in the company. And, you know, Shell is a company that's built on a foundation of technology and research. I think it's fair to say kind of lost our way maybe somewhere in the last 15 years or so, and in the last 5 years or so has really pulled back to that technology focus, and a company that knows that will define the success of this company in the future. And we split that thinking up and those investment dollars up into several categories. Like, you know, what are the core technologies we need? What are the things we need to just improve what we're doing today? And what are more the emerging technologies? Things that, you know, we have some sense that they may work, but they still require quite a bit of demonstration and investment. And then we go to the, you know, the game-changing technologies where we don't have really any idea what's going to work, but we as a company make the decision to provide the seed money and to work with research institutes and a lot of the universities that are represented here to make sure that we're involved in those and we help stimulate those.
Very, very good. Other questions? Yes, ma'am.
This is way too specific, maybe.
No.
But it kind of inspired me with your floating LNG. Is this deployed anywhere yet? Or if not, if you're really introducing it as new, where do you think you're going to deploy it?
So this will be the first, this is on the floating LNG piece. I'll repeat some of these in case you can't hear them in the back, but for this floating liquefied natural gas technology I'm talking about, we are actually building it now. So we've started that process. It'll take several years to do it. We're going to deploy it offshore Australia. So we've already picked the location and made that final decision investment to move forward. And I think it's probably 3 or 4 years before it'll start producing, but it's real. It'll be the industry first, but it's real. And now we're in the process of looking at, you know, where are the next 2, 3, 4, and 5 places that we could apply that, and it really applies all over the world. And let me just say too, there's no question too specific. So I know, you know, sort of waved at a high level in the prepared remarks, but if you want to talk about shale gas or what it looks like in Eagle Ford or to, you know, a specific kind of research, just ask. Yeah, please.
Bill, let's go to Bill and then we'll come here.
Okay.
Go ahead. Yeah.
You fired my imagination when you said you might be interested in looking at how efficient energy sources at the level of the mitochondria could be translated into energy of the type that Shell might produce. Give us a little more thoughts on that. How would you do that?
Yeah, I very purposefully threw that thought into the room because I have no idea how to get there. But I know there's some very smart, you know, Shell researchers that are in the room and others that I know can help figure this out. So that, you know, my job is to put the challenge out there.
Wow.
If I had a real good linkage, I actually would have given it to you in the
Thank
speech.
you.
But
Anyway.
but there has to be something there, right? There has to be something in the way that works that we can translate. Yeah.
With regard to some of your,
Oops.
with regard to some of your more advanced technology projects, I was wondering, you've had almost a year now with the Pearl project in operation. Do you think it's going to, if you run into problems in the startup, does it look like it's going to be profitable?
Yeah, so let me just give everybody a little bit of background on this. The Pearl project, which we started up in the past year, so we've actually been running a little over 6 months now. And we're coming up in 2 phases. Let me give you something to think about first. This is probably the largest single oil and gas project in the world when it started up in 2011. It's about a $20 billion single plant with the singular purpose of converting natural gas into liquids that can be used like liquid fuels. So I don't mean like liquefied natural gas where you put temperature and pressure on something to reduce its volume. I'm talking about a chemical permanent conversion to a liquid product, which makes ultra-clean diesel, base oils, very, very high-performance oils and that type of thing. So we started up this project. It's an enormous project, as I said, in Qatar in 2011. We're still in the ramp-up phase, so we haven't even brought on fully the second phase of the project yet. I think this is going to be a breakthrough piece of technology. So the bottom line is that it is working. It's actually working well. We're having some of the normal startup issues, if anybody can imagine a $20 billion plant, getting every piece of equipment to run in exactly the right synchronization and so forth. We're having our issues with startup, but I'm pretty excited about, and we're all excited about what we're seeing. And the next place we'll be talking about a gas-to-liquids plant will be in the U.S., because what we see is an abundance of natural gas, very low natural gas prices. We see high oil prices, and we see a market that has to import so much of its liquid fuels. And you can see the fundamentals come together pretty quickly if the technology works to do something like that in the U.S. So I think you'll see more of them in the future.
Now you have a microphone.
Okay, got it. Can you talk a little bit about oil spill remediation in the Arctic?
Yeah, as a matter of fact, I'll be talking a lot about that for at least the next 7 months. And the reason I say that is we've been trying to drill offshore Alaska for quite some time. It looks like the summer of 2012 may be the time when we actually do drill offshore Alaska. We've effectively received the major permits from the government so far. We've got a few other, not insignificant hurdles to get past in terms of those permits, but it looks like we'll be drilling. So the thing I spend a lot of my time external to the company talking about is how do you prepare for, how do you prevent, first of all, and then prepare for and react if you had any type of spill in the Arctic. And I think the biggest challenges typically come to me from the framework that says, we saw what happened with Macondo in the Gulf of Mexico. And that's an area where there's tremendous amounts of infrastructure and resources and so forth, and look how difficult that was. So you have to begin from a standpoint that says, what's different about drilling in the Arctic? And I just want to draw a line to a couple of differences there, because if you're watching the energy business, this may well be on your mind, particularly if you're concerned about the environment as well. And that is the situation is completely different. So we're in the maximum, probably about 150 feet of water when we're drilling in Alaska. The pressures are a third probably, or even less, of what we're dealing with in the Gulf of Mexico. So the real issue for drilling up there, and the safety issue, is the fact that it's very remote, and that at some point in time, ice moves back into the region and hampers any sort of operation that you might have there. Now, what that causes a company like Shell to do that wants to drill in the Arctic is it causes us to take that entire response capability with us to the Arctic. So unlike a Gulf of Mexico or anywhere else in the world, where if you have an accident, you mobilize resources from all over the Gulf Coast, from Singapore, from all sorts of places in a very well-organized fashion, every piece of response in Alaska is available within a 1 hour's notice. So you're there on site responding at low pressures in shallow water where you actually have access to equipment, and it's a much different situation than I think most of the world watched in the Gulf of Mexico. So we take it all with us. We respond within an hour. We've added equipment since the Macondo response that allows us to cap and contain and flow to surface any oil that's leaking in case we needed to, and capture it in a barge. So there's a new grouping of infrastructure and capability that will be up there before we start drilling. So now I focused on the area where I wanted to focus, which is all about, how do you, and I didn't actually go to the prevention side, but how do you react if there's a spill? We also have done and continue to do a lot of research about cleaning up oil if there did happen to be a spill in Arctic-type conditions. And we found, in particular, Norway to be very, very helpful in this respect. So some of you might be familiar with SINTEF. So SINTEF works very closely with us in the industry with actual oil and water to test, everything from skimming to burning to, other remediation type effects. All of that combined, which has been part of our permit into the government, was included and is seen as being sufficient to move forward. So if you want to catch me off to the side, we can talk more about it, but I know there's a lot of people that are uncomfortable about that. Yeah. So the answer is no. The question is, have we decided on a location for our ethane cracker in Pennsylvania? So the reason why this type of manufacturing, chemical manufacturing basically, coming back to the U.S. and coming back to a place like Pennsylvania is again tied back into the natural gas discussion you had this morning, because now there's liquids-rich, low-cost feedstock, if you will, into a chemical plant that didn't exist before in the United States, so or at least hadn't existed in a long time. So that's what makes something in the Pennsylvania or the Marcellus area attractive. We're talking to a couple of states up there right now about where it would be, so it's not even just Pennsylvania, but no decision on that yet. Please.
Would you comment further on your alternatives for energy storage? There was some discussion in the earlier session, but for those intermittent production sources such as wind and solar, various technologies, any breakthrough, any new ideas other than compressed air or elevated water storage, other alternatives in that area for storage of intermittent production?
Well, I wish I had some good ones for you, because before you mentioned them, I was going to mention some of the old traditional tried and true methods that are not particularly economic, but about the only way we know how to store that sort of energy right now. I do think this is an area, I talked about our game changer sort of technology focus, where we want to put seed money into areas that will help develop certain things. Storage for intermittent power sources is absolutely one of those. So my guess is I don't have any real technology comments to add on what you heard this morning, but I do think it is obviously a primary area for us as a company. I think for any nation looking at its energy supply to figure this piece out. In the short term, it's one of the reasons why you'll see quite a bit of advocacy for Shell coming out in the form of natural gas, and there's a couple of angles to that. One is, of course, there's a lot of it, but it's not as simple as that, because this is an advocacy that crosses everywhere in the world. And it is all about, if you're really looking to, if reducing CO2 emissions and other emissions is part of what really gets you motivated, then it's pretty clear to us that the easiest, fastest, and the affordable way to do that is shifting to natural gas as a power source. But one angle of that advocacy is very much that as we bring on wind resources and other intermittent resources, the best thing until we solve the storage problem to match up with that intermittent power source is natural gas-fired power generation, because you can flip it on and flip it off, and it becomes very complementary to the alternatives.
Yes, sir.
Back in the 50s, a famous Shell oil company Jim introduced the concept of peak oil. So as you look forward to 2050, I was wondering how peak oil factors into the concept. Trying to map that out.
Yeah, I don't know that it does really, and I think certainly we always take a view of what resources are left. Where can they be discovered? Where can they be produced? Is that from everything from a technical risk to a geopolitical risk? How does that work into the equation? So I don't want to give you the impression that we don't have that view of the world, which we do, and we update probably on almost an annual basis. But the other thing that I think we have to recognize is, the natural gas situation, for example, in North America. I don't think anybody, other than our pioneer here, I don't think too many people really contemplated the fact that that resource was going to be available at the quantities that it is just, a handful or two of years ago. And I think it's revealing in terms of how much that picture can change. And, we work in the oil sands in Canada. That's a process that we're always looking for a way to improve, because it has some environmental impact. It's basically a mining operation to recover this oil. But there's unbelievable amounts, and I can tell by your question you know this. I mean, there's Saudi Arabia quantities of oil in Canada that if we figured out a new technology, maybe a nanotechnology, maybe an in situ conversion technology to take it from heavy to light sources, all of which we're doing research on. If If you could find a way to convert that in an environmentally secure way, that would completely change the picture again. And I could say the same thing, just sticking to this continent, I could say the same thing about the oil shale, you know, this very immature kerogen type material that exists through, you know, Colorado and Wyoming and Utah and some other areas. So we look at it, we think there's a good chance that with those kind of technology breakthroughs, I think, let me just say, there's an equal chance that we'll shift to other energies before we run out of oil and gas. I think that's probably a fair statement.
One more? Yes, sir.
From a regulatory point of view, for the federal government, what do you think from a regulatory point of view, what do you think the federal government should be doing to balance, the nation's energy needs with, environmental preservation?
Yeah, for me, it's, this story could be as complicated or simple as we want to make it. But let me give you sort of the simple story, which is for all of these resources that we talk about, the shale gas that you've talked so much about today, even to the extent of the oil sands I mentioned a minute ago, there are ways to do this right, and there will be ways to continuously improve how this is done. And I think, it's why you see companies like Shell, and we're not the only one by any means, coming out with things like these development standards that cover everything from working with communities to the direct emissions and environmental impact of what you're doing, and saying this is the current technology standard for how this should be done. And we're not doing that just so I can stand up here and say, here's the way Shell does its business, give us a pat on the back for doing it this way. We put it out there in that sense, in that level of detail, and there are thousands of pages that back up those sort of high-level statements, so that regulators can take that and I hope actually put that into law, make that the minimum requirement, enforce the law, and actually push this entire industry to somewhat of a common level of performance. And then continue to adjust that as technology makes other methods available into the future. And it needs to be a process of continuous improvement. But I do think there's more that could be done on the front end of that statement now.
Marvin, thank you.
Yeah.
Really appreciate
Thank you,
your
David.
time. I'm sure we could go on with questions for a long time, but we'll let you have a little break. We greatly appreciate you being here, Marvin, appreciate your message. I don't think you'll find any group anywhere that will be more in favor of the sort of collaboration that you propose than this one. So thank you for bringing that thought. And we greatly appreciate the leadership of you and your colleagues at Shell as we all work together to find a more safe and secure energy future. So thank you very much.